the second part of the research. Hope you all have already seen or visited the first video of this channel, which was all about the importance of research, how community medicine will help you to understand the basics of research, and also what should be the quality of research, why evidence-based medicine is the way forward, and all these things we have already discussed in the first video. Please, those who haven't watched the first video, this is the continuation video from the first video. So if you have not seen that first video, it will be very difficult to understand the way forward. So I would ask everyone who is watching this video, please watch the first video of this channel, that is introduction to community medicine and importance of research. Then come and see this video, then it will be very helpful for you. So coming to, as I told you in the first video, the basic science behind research is the science of epidemiology. I told you the definition, the word itself. The word epi means among. The word epi means among, and demo means population, and ology means science. That means among population science. So it's very easy to understand. It's among population science. Now, what is the proper definition of the epidemiology? Epidemiology is the study of how disease is distributed in the population and the factors that influence or determines the distribution. In simple, two words you have to remember when you learn about epidemiology is, it is study of distribution and determinants of health related states and events, and using that knowledge to prevent disease in the community. So it's very simple definition. Many times people don't say answers for your Viva as well as for your PG exam. Once again I will say, epidemiology is concerned with, one is distribution, that is concerned with how disease occurs in the community. For example, COVID-19, when we say the mortality of COVID-19 is very high, or morbidity of COVID-19 is very high in the older age group, whereas diphtheria, pertussis, or maybe polio affects mostly in the younger age group. They are inflicted in the younger age group, but certain diseases are distributed in such a way that they occur in certain seasons only, or they occur only in certain seasons. And also what is a pattern, where what time it occurs, what place, in what geographical location. For example, dengue fever, malaria, etc. are very prevalent in tropical climate. So climate is important, the place of occurrence, to whom it occurs, who is more labile to the disease. These all patterns we study in the science of epidemiology, that is distribution, how disease occurs in the community, and what is the number of, that is prevalence and incidence of the disease. What are the new cases reported about the disease, what are the new cases of the disease, and also what are the new and old cases, that is the prevalence, what are the new cases, that is the incidence also. These all things we try to understand in the definition of epidemiology. So epidemiology study how disease is distributed in the population and the factors that influence or determine the distribution. Why does a disease develop in some people and not in others? The premise underlying epidemiology is that a disease, illness and ill health are not randomly distributed in human population. They are not randomly. The disease don't occur like you take a lottery ticket. No, there are a lot of factors which determine occurrence of disease. So what are the factors which determines, for example, for cancer, certain types of cancer, there are certain risk factors. For example, lung cancer, it's very common. Lung cancer is very common in people who smokes, who are having a habit of smoking. Alcohol use is also a risk factor for certain cancers, and also the environmental condition is also a risk factor for certain cancers. So risk factors, if the certain human beings are exposed to certain risk factors, certain diseases can occur. And also diet is a very important thing for diabetes. And also if you take high salt intake it is high chance you get hypertension. And also, if you have a very morbid lifestyle without any exercise, you are having a higher risk for coronary artery disease. And if you have a high addiction for smoking, you can get peripheral vascular disease. If you have if you don't have any control over the diet, if you have diabetes, then you can have kidney failure. So every disease are having certain risk factors, and there's certain things which determines the course of the disease. So these all things we try to understand in the science of epidemiology. That is why epidemiology is the science which helps us to develop evidence, so that using that evidence we can treat the patients. Okay, now the two main measures of disease frequency. I told you frequency, what is the number of disease, whether it is small, new. For example, nowadays polio, even one case of polio is considered very dangerous to the population. Why? Because we have already eliminated polio. But a number of cases, malaria cases, for dengue cases, every year we are getting 1,000, 2,000, 3,000 cases in certain states. But we do not consider that as a big epidemic, because every year it is seasonal, certain 1,000 cases occur. But one case of polio is considered very dangerous, and it is can be considered as an epidemic. So disease frequency differs from one disease to another. So what is prevalence? Prevalence means simply, what is prevalence? Prevalence means P, the new cases of a particular disease plus the old cases. For example, diabetes. If we find 10 cases in a district today or in a panchayat, and if we have existing 90 cases, that equal to 100. So this is the criteria. We take these 100 cases in the population, okay, divided by the exposed population. So this is used for calculating the prevalence. But in case of incidence, we will have a different class for the calculation of this, don't worry. Incidence equal to only new cases. If 10 cases we take, only the new 10 cases are added. Okay, the 10 cases are taken into consideration when we calculate the incidence. The formula and all, we will have a different session altogether, don't worry. These measures are used to describe how common a disease is in population over time. That is very important, how disease occurs. For example, COVID-19, during the first wave, it had a peak, then it subsided. And in second wave, they had two peaks, then it subsided. So the peaks of the disease, when does for example, in food poisoning, there's a big peak when the people get consumed, when people consume the food which is which is already adulterated, or it is not good, contaminated food. If you take, there is a peak of cases for 1 or 2 days, then it subsides. So the number of cases is very important. So what is determinants? I told you two words are important. One is distribution, second is determinant. Determinants, what causes the disease, what actually causes, what are the risk factors, or what are the determining factors of a disease, is what is very important. For example, COVID-19, we are yet to understand what caused the virus to jump from animals to the human beings. That is yet to be found. For many diseases, for example, cholera, we found out it is the bacteria which is found in the polluted water which is causing it. Typhoid, and all diseases have determinants which cause. What are the causing factors of a particular disease? Cancers, diabetes, all diseases have determinant factors. So we need to find out what are the determining factors of the disease. That is also coming under the ambit of epidemiology. Now, before going into study designs, that is the main agenda for today's class, you need to understand the basic concepts of association and causation, because these two words are very important to find out the determinants of the disease. What causes, if you want to understand what causes the disease, we need to understand the concepts of association and causation. Okay, what is association? Two variables, A and B, are said to be associated if they are seen together more often than by chance. For example, you have a friend you are, for example, your name is A and you have a girlfriend B. Okay, in your college, or there is a cafeteria. Okay, there's a cafeteria in your college. Let me draw that cafeteria. Okay, so both these A and B, your name is A. Let me call you Varun, and you have a girlfriend Neha. Okay, both Varun and Neha are seen in a cafeteria for one day by the professor of the college, or the, for example, community medicine professor saw you in the college for a first day. Okay, so he understood, okay, you both belong to a certain batch of MBBS, for example 2022 batch. Okay, you both belong to 2022 batch. So when he saw you, he understood that he's a professor, he knows you very well because he takes classes for you, and so he understood that you, as you belong to the same batch, it might be a coincidence or by chance that he have seen you in the cafeteria when he came for taking the coffee. Okay, now first day he saw, now the second day he saw, same time 11 a.m. third day he saw, same place, same cafeteria, both persons, Varun and Neha. Fourth day he saw Varun and Neha coming under the cafeteria. Fifth day he saw the Varun and Neha coming under the cafeteria. Sixth day he saw Varun and, so for 1 week, 2 weeks he saw continuously Varun and Neha are seen under the cafeteria for 2 weeks. Then he suddenly realized these two variables or these two people are seen together more often. Now they are not seen together because of chance. Now they are seen together because they have a very good relationship. We cannot name that relationship unless and until now we know that relationship, but they have a very good friendship. So this can be said, A and B can be said to be associated only if we can say that there is a genuine relationship between the person, not by chance. Now this professor is seeing Varuna and Neha not by chance. Every day of the month, they are 11 a.m. they are seeing in the cafeteria. So this is not by chance. Likewise, if we want to say two variables, like for example smoking and lung cancer, if I want to say these two variables, smoking and lung cancer, are associated, they should be seen together. Whenever or wherever there is high incidence, high prevalence of smoking in a particular population, there should be increase in the amount of lung cancer. Did you understand? Then I can say, so it should not be random, not by chance. Not by chance somewhere in some population, some people smoked and you got high incidence of or high prevalence of. No, that's not where the science works. Science or modern medicine understands by removing the chance error. That is the beauty of modern medicine. By removing the chance error, we will understand the truth of what is the real truth in the ground, on the ground. So here the two variables, smoking and lung cancer, are said to be associated only if they are seen together more often than by chance, like Varun and Neha. Now we have to remove the chance error, whether these are seen together just due to chance or not due to chance. That we have to remove statistically. That is where statistics comes into forefront. I will teach you statistics, don't worry. I will teach you epidemiology, don't worry. I will teach you the basic concepts of the epidemiology, don't worry. Okay, so association, now you know it is the two variables A and B are said to be associated if they are seen together more often than by chance. Now coming to causation. Causation is different than association. Causation, if two variables A and B are said to be associated, if two variables A and B are said to be associated, we cannot say that A causes B. Okay, For example, Neha and Varun are seen together in the I cannot say there is an affair going on because I don't know what is between them. I am just seeing them together having a coffee. That doesn't imply anything. So if I want to know what is happening between them, I want to know what is the right quality of their relationship. So I have to talk to them and understand. Likewise, if A and B are said to be associated, that is the first step. First way to find whether there is an association between A and B. Now the second step is to find out whether A causes B. A causes B. For that, we uses the Hill's criteria of causation. The Hill's criteria of causation is a criteria which used to identify whether A causes B. For example, lung cancer is caused by smoking, whether smoking causes lung cancer. If all these, most of the criteria are met, then we can say we have to test whether these criteria are there. Okay, for strength, for example, I will say whenever there is high incidence of smoking, when smoking is increased very high in a society, there is more likely that the lung cancer will also high. For example, the risk of lung cancer in a person smoking 10 cigarettes and 30 cigarettes are not same. The person who is taking 30 cigarettes per day is at a higher risk than a person taking 10 cigarettes. This is called the strength of association. This should be proved that when the strength increases, so in the strength of the association, how stronger the association, more likely it is the causal. For example, I wanted told about the the example of higher intake, higher smoking numbers per day and higher chance of lung cancer. Likewise, what is the consistency? Association is observed. Association is observed consistently in different studies, and for example, it should be consistent in Europe. For example, if we learn COVID-19 vaccine is very effective in Europe, it should be effective in America, it should be effective in Asia, it should be effective in Australia. So it's very consistent in all parts of the world. So we can say that COVID-19 vaccine is a variable A. Vaccine is effective in effective in decreasing, effective in COVID-19, in dealing with COVID-19. Even for dealing with COVID-19 vaccine is very effective, that we can say by using the term consistency of the, that is one criteria for causation. Third is specificity. A specific cause leads to specific effect. For example, there are n number of risk factors. For example, pollution and intake of alcohol, and also drug abuse, and along with that you have alcohol, and along with that you have smoking, and you have lung cancer as an outcome. So we cannot precisely state that if that is the variable we are learning, we cannot precisely pinpoint. If a person is using everything, then we cannot precisely pinpoint smoking is the villain here. So we have to have a definite criteria where A should be specifically causing B. For example, lung cancer should not be that prevalent as in smokers, as in alcoholics. And also, lung cancer should not be very prevalent, high as in smokers, as in other risk factors. Then we cannot say it's specific. That is the specificity. Now, temporality. The cause must precede the effect. Very simple. The lung cancer is occurring on 2018 March. If he is smoking afterwards, after 2018 October or November, we cannot say that lung cancer is causing smoking is causing lung cancer. It should precede the event. That means it should have been from 2017, 18, 16. He should have been a chronic smoker, which led to the lung cancer in 2018. Okay. Now, plausibility. I always say it should be biologically explainable. pathologically, microbiologically, and also in the biochemistry ways, we should be explain what is the science behind the on the causation of lung cancer by the smoking. Plausibility, that is biology, and coherence, and all the knowledge, valid knowledge around us should converge to a point where we can confirm that. Then only we can say A causes B. Now we have, from the first step, A is associated with B. Now we say that no, A causes B. That is the beauty of the medical science, the beauty of science, where we are now eliminating the chance error by association. Now we are proving, now it is very near to a fact, we are stating A causes B. By using all these criteria, now we know. So earlier in 1990s, before 1990s, in all Hindi films and Bollywoods, Amitabh Bachchan smoking and showing his, he's very brave and he is very heroic in the before 1990s. So there is a specific shift after the 1990s in every part of Indian film where smoking decreased, and now if somebody is smoking in the film, there's a statutory warning which was not there before 1990s. Why? Because we had this big good study of Dole and Hill study which happened in the 90s and from 1960s, etc., which proved that smoking is very harmful for human beings. It causes those who are smoking, there is a high risk factor for lung cancer. That is the beauty of science. Science can transform human life. Science can transform how we think. Science can transform how we behave. That is why in Constitution is written is a scientific temper. A country should have the scientific temper. Then only a country can develop. Okay. Now, I've told you the research part. We know what is the research, the process of answering question using appropriate data. What is the frequency of disease? These all be descriptive research. What is descriptive research, etc., etc., etc. We learn in research. Okay, thank you for your time. So this is a short video. So